In Module 2 of Chapter 9, we're going to look at put-call parity, and we'll take a simpler approach. And in Module 3, we'll advance some of the understanding that we have of this relationship. So we're going to introduce the basic idea in two versions, because each has a value in developing intuition. So in version 1, we're going to develop the basic idea of put-call parity, and we're going to look at two portfolios. We'll start at portfolio A. We're going to go long a call on it, and we're going to go short a put on the same stock. Long call, short put, both with the same strike K, both with the same term T. That's portfolio A. Portfolio B, we're going to do a long forward contract on S with a forward price of K. Again, same term, term of T. When we get to time T, these two portfolios have the same maturity value. Namely, they both have value, the value of the stock minus K. So if the value of the stock is greater than K, there's a profit in either of these portfolios. If the value of the stock is less than K, there's a loss in each of these portfolios. Let's understand this. So if we look at portfolio A, here's our strike of K. What does a short put look like? Well, a short put is going to have a payoff profile at time T. This is the stock price at time T, and that's going to be our short put. If we look at a long call will have a payoff with a strike of K that looks like this. And so if I have a long call and a short put, the payoff at time T is this solid line. Now, if I have a forward contract, you're familiar with the payoff function of a forward contract at maturity. K is the forward price, and we're looking at S as a function of T. We're at maturity, time T. A forward contract, a long forward, is the obligation to sell. So if the stock price is above K, we make a profit. If the stock price is below K, we take a loss. And you can see that at time T, the payoff profile of the two portfolios is identical. What does this mean? Well, if they both have the same value at time T, it must be the case that they both have the same value at time 0. Why? Well, if one was more expensive than the other, we could do an arbitrage. We would sell the more expensive one, and we would buy the cheaper one, put a little profit in our pocket, knowing that when we get to time T, these two portfolios have exactly the same payoffs. So the long position will provide us exactly what we need to cover our short position. So arbitrage requires that if they have the same value at time T, they must have the same value at time 0. So if we write that expression down, we're saying that the value of the call minus the value of the put, this is the price of the call. Notice K and T are the two parameters, strike of K, duration T, that a call minus a put, that price has to be the same as the price of a forward. What's the price of a forward? It's the present value of the forward price minus the strike. So this is, if we write it this way, notice that that equation gives us information about when the call and the put have the same value. Namely, if we go back just for a moment, we have that the call minus the put is this expression on the right. So when is the call equal to the put? When the expression on the right is 0. So what we see is the expression on the right is 0 exactly when the strike price is not the stock price, but the stock price accumulated with risk-free interest. So that observation we had on the IBM table is sharpened here, because now we see that when there's no dividends, and we'll adjust this when there is, when there's no dividends, calls and puts have the same price exactly when the strike is the forward price of the stock. We're now going to look at the same basic idea version 2. It provides a different intuition for put-call parity, which is valuable in practice. And we're again going to look at two portfolios, portfolio A and B. But now A is going to be a call on the stock and the T-bill with a maturity of K. A call and a T-bill is a natural portfolio because a call provides you with the option to buy, and of course the T-bill with a maturity of K provides you the funds to do the purchase. So it's a natural package. Portfolio B is one share of the stock and the long put. In the same way that a call and a T-bill is a natural package, so is a share and a put. Reason is, a put is the option to sell a stock. Well, if you own the share, you have the share to sell. So it's a natural pairing. Once again, we can conclude that at time t, these portfolios have the same value. And in fact, the value will be the greater of the strike price K and the value of the stock. So let's see why that's true. So if we look at portfolio A, first of all, we have a T-bill. So we'll do the call first. First of all, we have a call, and the call payoff, as we've seen before, familiar payoff at time t. The T-bill, of course, has a payoff that's exactly equal to K. It's risk-free. So if we add these two, what do we get? We get this. So portfolio A has a payoff profile, and we can see that it is the greater of K and the value of the greater of K and the stock. So now if we look at portfolio B, portfolio B is a put. So familiar payoff profile of a put. We also have a long stock. So the value of the stock is exactly that. And if we add these two payoff profiles together, this is of course K, we can see that they will add together to be exactly the same profile we had earlier. And we can do this algebraically by writing down the definitions of the payoffs. But graphically, it's just as easy to do. So in the basic idea, the version 2 of it, because portfolio A and portfolio B are the same, once again, they have to have the same value at time 0. Reason, again, arbitrage. If one is more valuable than the other, we sell the more expensive one, we buy the cheap one, and we do an arbitrage. So if we write that expression down, the value of the call, portfolio A, is a call and a T-bill. And there we have an expression, the call price plus the price of the T-bill. That has to be equal to the time 0 value of portfolio V, and portfolio B is the value of the stock plus the put. So we can rearrange this. This again gives us the same equation we had earlier. It's just a different way to think about this relationship. And we come to the same conclusion that call prices and put prices are the same when the strike price is the forward value of S.